Hello, everyone. Today we're going to chat with one of our Fubon innovation scholars, my colleague João Sedoc, who is an assistant professor in our Department of Technology Operations and Statistics here at NYU Stern. Our Fubon innovation scholars are, they stand out for their interdisciplinary research in addition to their contributions to their own field. João's an expert in generative AI, in large language models, and in conversational AI more generally, which we'll talk about. You may have seen our interview with a data science chatbot, job interview of a data science chatbot a little more than a year ago. If you haven't, go look it up on YouTube. It's worth the time. You can just search on our names. I'm Foster Provost. I'm the Ira Rennert Professor of Entrepreneurship here at NYU Stern, Professor of Data Science, Professor of Information Systems, and I'm the Director of the Data Science and Artificial Intelligence Initiative at the Stern Fubon Center. Welcome, João.
Hi, Foster. Thank you for having me.
Yeah, thanks for taking the time. So probably everyone watching this knows at least one conversational AI system, and of course I'm thinking of ChatGPT. I wonder if you could tell us a little more generally about conversational AI systems, since I understand at least that there's more to it than just ChatGPT.
Yeah, so there's actually, ChatGPT is one of the most successful conversational AI systems. But there are many different types of AI systems beyond just ChatGPT. ChatGPT falls in a class of conversational interfaces that we generally call question answering. But there are more than just question answering style interfaces. For instance, there's information seeking, like we remember at old call centers where people were trying to find what kind of problems you have. Or there's more sort of conversational entertainment, for instance, now. Non-player characters and video games that also have a very sort of conversational style. And so the interfaces really do vary. Along with the variation in the interfaces, so does the variation in the modality. So by modality, what I mean is that we can communicate with ChatGPT mostly through text typing, but we can also speak to it. Now there's embodied agents, either virtual agents or even robots that are coming into play. And so each of those really encompasses what we really mean by conversational interfaces and conversational agents.
Yeah, that reminds me of with our interview. Actually, it was it's quite interesting actually conversing with the avatar and having it sort of actually talk to you. That's so one of the topics that I know you're interested in is empathy in these conversational interfaces, and I wonder if you can explain that. I know I read your paper, of course, on that in which you build empathy estimation models. You build a pretty complicated data set of conversations that are annotated by empathy and other things. Why should we be caring about AI systems' empathy?
Yeah, so I think now that conversational AI has really gotten better, meaning that the quality of the output of the system has improved, one of the things that we can see is that we're having more human-like conversations. And empathy, or the ability to understand the feelings either with or for someone, is a fundamental trait of conversation. And it's a fundamental way that communication can be good or better. And so in order to have more human-like conversations with people, we want these agents to exhibit empathy, not always, but in certain situations. And so it's actually a very important sort of dimension for these agents to improve on. And what we're trying to do in this data set and this sort of line of research on building more empathetic and emotionally responsive conversational AI is to basically build features into the AI system which allow it to not necessarily understand emotion, but be able to predict what kind of empathy and emotion the person is feeling. As a result, what we've done is we've created a data set where people can, we actually look at the amount of empathy that people are expressing, both what their internal state empathy is, what empathy perception is, and how third parties look at the empathy as they look at the conversation. And so this provides a kind of a holistic set for us to start to model this in order to then incorporate that kind of empathy in sort of downstream applications for, let's say, conversational AI around clinical behavioral therapy or behind sensitive topics.
So do we know that empathy, where's the research on this? Do we know that empathy is actually, systems having empathy actually improves their performance?
So what we do know is in fact that for certain types of conversations, that improving the amount of empathy between people and also the empathy that's observed between the person and the conversational AI correlates with overall quality of the conversation. So that is not to say that there's necessarily a causal relationship, but we do know that there's a correlative relationship. And in terms of being able to see the type of rapport building between the empathetic conversational AI and the person, we know that that also increases as we, increase the amount of empathy in the agent. So we've in our research, we've absorbed this. Other people have also been working on this and seen sort of similar findings.
Interesting. So something that, this brings up something that you and I know you are, and I am both passionate about is the evaluation of AI systems. I think actually this is like one of the most important aspects of the development of AI systems in business, and at the same time, one of the least talked about. Can you tell everybody a little bit about what's the state of evaluation specifically for conversational AI systems?
Yeah. So conversational AI systems are complex systems, given that they're built in business, especially within a larger infrastructure. And so the main sort of outcome that many people are looking at for conversational systems is, okay, task completion, right? After that, for the larger scope, there's a lot of work on post-fact surveys. So a lot of people will have, let's say, in a lab, like in my case, where we do a lot of this, or sort of post-hoc surveys after, like we all get after we talk to something, there's a survey that pops up. Those are sort of one of the most common instruments in order to measure. However, there's other forms of evaluation, like looking at chat logs and doing annotations to understand when certain parts or turns in the conversation have broken down. There are other aspects of evaluation, like deciding or seeing if certain slots that are expected to be filled. So let's say you're trying to book an airline, you need to know where you're going to. Right? Those are other aspects of the evaluation. So there's a lot of different dimensions in which people are trying to evaluate these systems. But we are now in an interesting time in a world where certain aspects or dimensions of the conversational systems have gotten better with the advent of these large language models. And they're exposing a bunch of new areas of problems, like probably the most prevalently talked about, which is sort of factuality and truthfulness, where we want to make sure that our AI systems are robustly founded or grounded in either world truth or corporate documents, and that these are in fact what we reply to. So we don't want, let's say, if somebody talks to our chat system, we don't want somebody to be able to ask, give me the coupon code, and for the chat system to hallucinate a coupon code where we never intended a coupon code to happen.
So maybe I'm getting a little technical for some people, but I'm curious now, given that the the base models are not trained to be factual, particularly factual, right? How do they go about making, sort of, let's just say they evaluate it and they find out, well, the sound seems like, 2% of the time it's actually not factual. What's the remedy then?
So I think that there's sort of a couple ways of doing this. One of the first manners of doing this is actually a lot of people are now using what are called retrieval augmented generation systems. And what this does is it basically has some set of documents, let's say, corporate documents or Wikipedia articles or what have you, that are considered sort of grounding information. And they retrieve that information and they give that to the large language models, which increases the likelihood of being able to say, what is grounded. Furthermore, oftentimes what will happen in a sort of a corporate setting is you'll also put the evidence, right? You'll give like, okay, this is, what it is, and here's like an actual extractive bit of information that basically relates back in order to like show the grounding. But when we talk about these large language models or the underlying technology sort of inside the conversational AI system, ultimately there's nothing in the model that is constraining it from hallucinating from a safe, pure sort of safety point of view. And so adding in other guardrails, for instance, one of the research that we're currently working on, we look at retrieval augmented generation, where we look at the knowledge of the corpus that we have. And then if something is close to or within what we consider answerable, then we're willing to actually say the answer through the AI system. Otherwise, we add the safety rail and say, hey, this is outside of our scope of knowledge. So that's sort of a more defensive mechanism in order to be able to have these guardrails.
I guess wondering, with the retrieval augmented generation, we're getting a bit deep here, but with the retrieval augmented generation, so the idea there for everybody, we talked last time, João and I talked on camera about this topic. We pointed out that the base level large language models that underlie ChatGPT and so on, right? The base level models don't have access, unlike what a lot of people thought, don't have access to a database that then they can go look stuff up with. They just have to sort of remember stuff, right? And so the retrieval augmented generation gives them access to a database as part of their input, possibly never seen by the user. So that's the idea of retrieval augmented generate, right? And so, but just giving it as input doesn't mean it's going to actually be able to find the right stuff in there. And so I'm just curious, what's the state of the art? How much like improvement in accuracy do you get? Is it pretty much always right, or is it like, well, that depends so much on X, Y, and Z?
So, alas, like many things in life, it's complicated. So it does depend on the use and context. Oftentimes, these models tend to not necessarily remember as much salient information, let's say if it was accidentally retrieved in the middle. We also have found, or other researchers have also seen, the fact that if the information that's being retrieved is somehow in conflict with the internal state of the large language model, occasionally it continues to its learned parameters rather than the retrieved documents. However, we have seen through many different experiments in many different settings in the community that retrieval augmented generation does, in fact, improve consistency, right, massively. However, the main thing to note is that while it does increase the consistency, this is a very business-dependent threshold, right? So if we've gone from 75% up to 98%, well, that may be okay in certain circumstances. And for instance, I work a lot with public health and healthcare folks, and for them, the 2% is too large of a margin of error. So again, that very much depends. And so this sort of leads me back to this work that we're doing on safety with retrieval augmented generation. And so the idea behind this work is instead of trying to say, hey, we're going to retrieve this data and then we're going to let it respond, we're only going to respond to input from the user, right? Whatever the user is asking to the system, where it's close to what we think we can answer with the system. So it's close to the knowledge of the documents. This does provide some safety in terms of the utterances, because now you know more clearly that you're grounded.
Yeah. Now, this really sort of also illustrates what those of us who build AI systems for a living know, that an AI system isn't just, oh, we have to like figure out how to prompt or how to train a model. It's obviously a complicated process of using a model in a complex system. But I introduced the interview by talking about how the Fubon innovation scholars are interdisciplinary, and you mentioned your work in public health. So maybe tell us a bit about, because I know you've been building real conversational systems for public health.
Yeah, so I worked with several people both at Johns Hopkins and now more recently at the NIH, where we're trying to actually build systems. At Hopkins, we were looking at COVID-19 information, sort of what information about COVID vaccines. Now we're looking at, with the NIH, we have a project where we're looking at trying to answer questions about substance use and substance use disorder in order to be able to support people better. And so the idea is that there's not always a clinician present. It's very hard to have 24/7 support, and these AI systems are 24/7. Right? That's the one thing that they're really good at, is always being there. And so the question is, can we build systems for them where what we're allowed to do is basically answer questions that patients may have, right? And these are sort of in relatively a high-stakes scenario. And so we're in the sort of early stage of this process where we're trying to start to prototype this with some of my colleagues.
Mm-hmm. And I know you have a paper on AI. Looking forward towards AI for psychotherapy. So are we going to have AI artificially intelligent psychotherapists?
Well, since our paper came out, I got that question a lot. So the answer is that I think what we're going to have is we're going to start with sort of AI assistive technologies. And those are more or less in place now. And so what AI assistive technologies are basically where you have a clinician and the assistant may be able to help phrase certain emails or certain messages with the patient in a particular way. One of the most recent findings is that ChatGPT can display more empathy than doctors do, right? And so here we have an automated way of doing some of the rewriting where it's a productivity gain. The next step I think that we're going to see soon is basically where we integrate the AI more into the process. And what this means is that it does summaries of notes. It helps with some suggestions about diagnoses. It gets incorporated into peer counseling, right? Especially online peer counseling, where we see that people aren't as well trained as, let's say, a clinician, right? And as a result, we can see that these components can actually integrate with life. However, there's the final step, which is really full automation, right? And to some extent, I think full automation really requires sort of a true understanding of the human experience, which is nearly asking for the assistants to be AI complete. And I think that's too much of an ask. So what we're going to see instead is probably systems which, instead of trying to sort of be automated therapists, what they're going to be able to do is to run automatically, where there are more people who need help and therapy than there are clinicians, right? So this will be able to help to give sort of maybe 70 to 80% of those questions, which accounts for the mass of a lot of what people need. But then, of course, the true answer to trying to get like a full therapy or different types of therapy incorporated, I think that's quite a far in the future for where we want AI to be.
So a couple of things come to mind there. One is this result that I recall a bit vaguely now from old medical AI system work, which one of the sort of non-AI things that they found out was that actually people were much more comfortable giving their personal medical data to a computer than to tell it to a person. And so I imagine maybe there's a phenomenon like that with respect to psychotherapy.
This has been repeated again and again, and it seems to be that people are more willing to reveal or self-disclose certain information. And the best working hypothesis is that it's because they don't see chatbots as being judgmental, right? And having that taken away allows for more communication or freer communication. This is actually in some sense, this is one of our main hopes for this substance use case for using these conversational AI is that, look, here's a system that you can ask it any question. You can ask it as many times as you want. It's not going to judge you. It may be empathetic in the right manner, as however, these clinicians are saying, okay, this is a correct way of being empathetic to patients under this circumstance, right? But it's not going to be, sort of talking to you about everything, being able to truly be a therapist, but at the same time, in terms of its ability to like gather information, it can actually be superhuman in its performance, possibly.
Yeah, and that got to this to the second notion that had come to my mind, which is well, at least as I understand, the people that I've known who've had long-term relationships with the therapists, right? The sort of input bandwidth that you have to your therapist is very small. Let's say you go once a week and you have 45-minute sessions and you're talking most of the time, but that's still 45 minutes worth of bandwidth that you have. Whereas you could see that if you have a modern technology, like a cell phone, and the cell phone incorporates this AI that is intended to help with your therapy, you could have a huge amount of bandwidth, and then I suppose the AI could, I'm ad-libbing now, but I suppose the AI could then sort of distill stuff for the therapist, sort of to prepare for a one-on-one meeting. Is that sort of thing being worked on?
So this is a current active area of research, and it's beyond just like the therapy. It's also just trying to get continuous patient monitoring, where basically we just don't have enough time, right, in our medical professionals to be able to get this information from people as often. And yet the technology is, right? The technology really can. And then the question is, like, can it summarize and distill the most important information back to the medical professionals who really who don't have bandwidth, right, to be able to do this. And I think that this is, to some extent, being able to distill important information is one of the sort of core things that we're seeing that this technology is able to do relatively well.
Yeah. So I guess with the time we have left, I thought maybe we could zoom out. Can you talk a little bit about what you see as the impacts of either LLMs or conversational interfaces that are just over the horizon?
Yeah. So I think what we're going to see is that these type of technologies are going to start to be integrated in businesses, right? And it's going to be integrated in many different settings. And even now already, we see that many different companies are trying to understand, okay, where do conversational AI systems actually benefit, right? Where are we getting the largest yield out of this technology, right? And there's sort of simple places like, okay, Copilot for coding, or integration into the Microsoft Office suite or G Suite. But when we start to look more at like sort of real office place practice, right, this is where things start getting really interesting, right? So summarization of meeting notes, like trying to actually get meeting notes, taking very large and complicated Gantt charts and trying to track them more easily. Again, humans are not great at like being able to track lots of features at the same time. And machine learning models over time have proven to be really good at this, right? Large language models and conversational AI systems are no different. They're very good at that kind of task. And being able to incorporate those kind of things into the infrastructure of what we're doing will be actually quite important for like where I think we're going to go and where these models are going to be able to increase productivity in workflows.
So where do you think we're going to go, let's say even a little more than just a little over the horizon, but maybe, and I know this predicting the future of AI is probably not what we should be doing, but let's do it anyway. Yeah, let's say 5-10 years.
I think one of the things that we're going to see is this sort of movement towards being able to have factuality, explainable systems. We're going to see that move forward very fast. And I think in about 5 years already, we're going to see that factuality in most sort of systems is actually really high because there's so much attention that's being played into them being factual. We're going to see this emotional capability and conversational capability start to increase. We're going to see this as like sort of really being able to see a lot of aspects of the user at once. So your calendar, your mail, your location, are all going to start becoming fully integrated into its sort of context of what it's able to do. What I think we're going to start to struggle with are sort of these like sort of safety critical applications. So anything that requires sort of hard safety constraints is also going to end up going, I like to call it the route of autonomous driving vehicles, where I think we're going to need new technologies, right? I think we're going to need, if we really want these, I think we're going to need symbolic or at least probabilistic logical constraints in order to be able to say, hey, if this happens, then that, and really have a full rule that's actually traceable and guaranteed, right? And that I think is, going to be one of those very sticky points in the future, right? Where those kind of applications and everything that falls within that category is going to be sort of problematic. And so we'll have to see where that goes. The other thing that I think is going to happen is I think we're going to have a lot more author attribution in our models. So our models are going to know more about the data that they're trained on, partially because I think what we're going to go is we're going to see more of sort of a licensing type of training scheme. Especially Europe is going to push this, but I think we're going to see this just generally. And so what that means is that the models themselves will also start incorporating in more of this author information, which will allow them to be more human-like in some ways, and will, sort of allow us to be able to encompass more responses to specific individuals, right? So it'll be more individual aware because it's also more aware of where documents came from, who is actually generating these documents.
And do you think, are you specifically thinking in the large language model itself or in the retrieval augmented generation process?
So I think actually we're going to have a little bit of both, but I think actually in both senses. We're going to see it. I think the retrieval augmented generation is a lot easier for the reason that we can tag those documents, whereas in the large language model, I think it's going to be much more complicated. because now we have to do this in the parameters of this like
But you
trillion
think that the
parameter.
existing architectures are sufficient to be able to do author attribution?
So that's interesting. I think that this is a really interesting point of point where we don't quite know yet. So the answer is, I think we'll know in the next couple 3 to 5 years. We'll know this well. I think so is my current belief, but I think that there's a good chance I could be wrong, like with any prediction. The other thing that I think that we're going to see, which is really just a function of the fact that these models need so much data, is that the models will start consuming anything they can. So right now, a lot of the models are based off of text, but we're going to see these models that are going to be based off of text. They're going to be based off of audio, video, images. They're going to be based off robotic actions, right? Actions in virtual environments. All of this information is going to be added into the training of the model. And specifically, the thing that I think is interesting is actually the training including actions, either in the physical or virtual world, which I think is sort of missing from the current set of models. And I think that new added feature training will be really interesting to see where that takes us.
It sure will. All right. So thank you very much for taking the time to be with us. Thank you all for watching, and can't wait till the next time.
Thank you, Foster.